Good evening, friends. It is the night of Unit 4, Lesson 9. Today we've been talking a lot about shifting and patterns and which way they go, left or right. So basically the two objectives we have tonight are review shift patterns for whole numbers and decimals. So we're going to kind of talk about that again. And we're going to explore shift patterns when multiplying by powers of 10 with exponents. Exponents are our favorite. So on your SAB page 145, I took a little section out, and I think it's important for us to, as we're reviewing and comparing how we multiply with whole numbers and how we multiply with decimals, I thought it would be good for us to fill in this top part. So if you have your SAB book, you can fill this in and you can post this as your evidence. But when you multiply by 10, the number, just as in 10 times 10, gets, I heard you, 10 times as great. The digits then shift one place to the left. So if you're looking at the screen right now, we're going to go this way. So that decimal point stays still. Those numbers are going to go this way. In comparison, when you multiply by a decimal or a tenth, the number gets 1/10 as great, and the digits shift one place to the, I heard you, right. So our decimal point stays still, and our numbers are going to go this way. When you're doing 100, the number gets, I hear you, 100 times as great. The digits then shift, you got it, two places to the left. This is review, friends. We're just comparing the likenesses and the differences between multiplying by decimals and whole numbers. So when you multiply by 100th, the number gets 100th as great. The digits then shift two places to the right. So how is multiplying by 10 or 100 like multiplying by a tenth or a hundredth? Well, multiplying, I'm just going to use this for shortness, but M is multiplying by 10 or a tenth results in a shift of how many places? One place. That is a similarity, right? Multiplying by 100 or 100th results, you guessed it, in a shift of how many places? Of two places. The difference and the overall difference, and I'm going to write this in a different color because these are our similarities. Right here are our similarities. The difference is which directions you're doing that shift. The difference is the direction you shift. That should be no new knowledge. That should be all the same knowledge. It's just kind of a review. So to practice this, let's do a couple problems. This is also on page 145, I'm sorry. And I just thought we could do these real quick. So we have a tenth times a tenth here. A tenth times a tenth on number 14th. So I could just say 6 times 2 is 12. But I know that 1/10 times 1/10 equals 100th, right? So if I'm doing 6/10 times 2/10, I should get 12/100ths. Here I see I have 300 times 9, which I know is 2,700. But I have a tenth here. So my decimal place is going to shift one place to the, these numbers are all going to move this way. So I should have 270 as my answer. Now number 16, I have 9 times 4 is 36, but I know that 1/10 times 100th equals 1,000th. Am I right? So I have 9/10 times 4/100 equals 36 thousandths. So right now I have 36 thousandths. Okay, guys, not anything earth-shattering, not anything new, all the same stuff. If I have 60 times 6 on number 17, I'm going to get 360. But I have 1/10. I'm multiplying by a decimal. So my 1/10 is going to shift these numbers one decimal place this way. So my decimal point's going to go, I'm going to move the numbers. I'm physically going to move the numbers. Ooh, that's a cool trick. Here's my decimal point, right? I'm going to move those numbers one place to the left. And the answer is 36. So these patterns, you're going to start seeing them, and it's really straightforward. But just to look at these with powers of 10. So 10 to the first power is equals 10. 10 to the second power is 10 times 10. That's 100. 10 times the third power is 10 times 10 times 10. So just to review, this number is called the, what is it called? Everybody should be saying, I hear ya, base number. Okay, and the number that's hanging is called the exponent, just as a review. That's how many times we're going to multiply that base number. So if I'm doing a 10th times 10, that's the same as a 10th times 10 to the first power. I'm going to shift that number to the, because I'm multiplying by 10, I'm going to shift it to the, I'm going to move this number here one place to the right. I mean, left. Oh, my left and right are all messed up. Sorry, guys. A 10th times 100 is going to move 2 places to the left, which this right here is the same as this right there. This right here is the same as this right here. I'm going to move this 3 places to the left. So let's see if we can apply that a little bit here, looking at the patterns and seeing if we can't, figure this out and see if you can see the patterns of what's going on here. So if I'm going an 1/8 times 10, or an 1/8 times 10 to the first power, which way am I moving that? I'm going to move this right here, one place to the left. So my answer is going to be 8. In the next one, I'm moving this number 1. So I'm going to move my numbers this, I'm going to move this, I want to show the magic. If I did point and then 8, I have to move this how many places? With 10 to the second power, I have to go 1, 2. Well, if I leave that empty space there, I haven't done my job. So this is 80. If I'm moving it a third time, if I'm moving the 8 a third time, I go 1. Oh, hey, hold on. I need those holders. This is going to be 800. So here I have 27, and I just wrote it as 72, sorry. I have 27 hundredths. If I'm multiplying it by 10, I'm going to move it one place because I'm multiplying by a whole number. So my answer is 2 7/10. Now, if I'm multiplying by 100, or 10 to the second power, I'm going to move it 2 places. 1, 2. So my answer is 27. Now, if I'm multiplying by 1,000, or 10 to the third power, I'm going to move it 3 places. Now here's where I want you to see the visual. 1, 2, 3. Hey, there's a gapper there. What do I need to fill in that gap? Or hold that place? 270. So I think you're getting the idea about how you're moving things. I don't want to make this video go on much longer than it needs to, but I think that you are starting to really see those patterns on which way we're moving things and comparing how to multiply by whole numbers and how to multiply by those decimals. Hope you have a good night. Don't forget to press down on Google Classroom and attach your evidence that you listened to me. Have a great day.